You know that sound, that deep, satisfying crunch as a hydraulic press does its thing. It's a viral sensation for a reason, right? There's just something so mesmerizing about watching things get completely, and I mean utterly, flattened. But have you ever stopped to wonder what's actually going on in that split second of destruction? Well, let's get into it because there is some seriously cool science behind the splat.
So why are millions of us glued to our screens watching this stuff? It turns out it's a potent mix of things. You've got the simple sensory thrill, the crunching sounds, the wild visuals. There's also this weird sense of relief, of catharsis, watching all that chaos in a totally controlled environment. And of course, there's just pure curiosity. What's going to happen when a bowling ball meets 100 tons of force? You just have to know.
But here's the cool part. Beyond just being satisfying to watch, every single one of these videos is a mini lesson in material science. So we're going to shift from the why we watch to the what is actually happening on a physical level. Because the way an object reacts to being crushed, well, that tells you everything you need to know about its internal structure.
The star of this whole show is something called compressive stress. Now that's just the fancy engineering term for the force of being squished. Imagine squeezing a stress ball in your hand, right? Now amplify that feeling by about 1,000,000. Every single thing that happens next, whether an object bounces, breaks, or just bends out of shape, is all about how its insides handle that intense, intense pressure. Okay, so let's put some everyday items to the test. In this next section, we're going to see a real showdown between different material properties, and you'll get to see exactly how these scientific principles play out in the most spectacular ways.
All right, our first contender is a simple rubber ball. We all know what it's supposed to do, right? It's supposed to bounce. But what happens when it meets a force it just can't handle? Let's find out.
What you just saw there is a perfect example of elastic deformation. The ball gets squashed completely flat, but then, poof, it snaps right back to its original shape. See, on a molecular level, the bonds holding the rubber's atoms together are stretching out like billions of tiny invisible rubber bands. They stretch, but they don't break. So once that force is gone, they just pull everything right back into place.
Now for something completely different, a regular old piece of chalk. This is pretty much the total opposite of a bouncy rubber ball. We know for sure it's not going to stretch, so what is it going to do?
And it's gone, just completely vaporized. That sudden catastrophic failure is a fantastic illustration of a property we call brittleness. Unlike the rubber ball, the atomic structure of chalk is super rigid. It can't stretch, it can't bend. So when that compressive stress gets to be too much, the bonds don't just stretch, they completely shatter. There's no warning, just instant disintegration. Okay, so we've seen something that bounces back and something that just shatters into dust. What about the middle ground? Let's bring in an empty aluminum can. You see how the can crumples and folds, but it doesn't fly apart? This is a great example of ductility, and it leads to what's called plastic deformation. Now, unlike our elastic ball, the can does not go back to its original shape. The force has permanently pushed its atoms into new positions. This property is actually what engineers count on to design a car's crumple zones. They're made to deform and absorb energy in a crash, which helps keep the people inside safe.
For our final demonstration, let's check out something a little different. A brand new deck of playing cards, still in the box. Now this isn't one single material, it's a layered one, and that changes the game completely.
Watch this really closely. Before the box itself breaks, you can see the cards inside start to slip and slide past each other. What's causing that is called shear stress. It's a force that acts parallel to the surface. It's just like when you shuffle a deck of cards, that sliding motion is shear stress in action. It's a totally different way for something to fail, and it's unique to materials made of layers.
Okay, we've had our fun watching the science of destruction. But this isn't just about making satisfying videos for the internet. Understanding how and why things break is absolutely fundamental to real-world engineering and, even more importantly, to keeping people safe.
First off, we have to respect the power we're dealing with here. A lot of the presses you see in these videos can exert over 100 tons of force. To put that in perspective, that is more than the weight of an entire blue whale, all focused on one tiny spot. This is not a toy.
And this is where we see a huge difference between the presses in viral videos and the ones used by professionals. The hobbyist press, it might have zero shielding. A professional one, it has mandatory polycarbonate guards. A hobby press might not have any pressure relief valves, but a pro setup has calibrated systems to stop it from overloading. And look at the controls. A professional press requires 2 hands, which makes sure the operator's hands are nowhere near the crush zone.
Look, these features are not just suggestions. They are absolutely critical. Without that shield, a brittle material like that chalk we saw can explode into shrapnel, flying at incredible speeds. Without pressure limits, the machine itself could fail catastrophically. These safety systems are literally the only thing standing between a cool video and a life-changing injury.
So this brings us to our last and honestly our most important point. I need to be crystal clear about this. The physics are fascinating to watch, but the reality of doing this yourself is incredibly dangerous.
I want you to let this sink in for a second. All the fun of these videos just vanishes when you think about the real-world risk for someone who isn't trained and doesn't have protection. Getting a few likes on a video is just not worth losing an eye, or even worse. So here's what you need to take away from all this. Please, enjoy the videos online. Appreciate the incredible material science you're seeing, but leave the actual crushing to trained professionals who have the right safety equipment. The forces involved are huge. The results can be wildly unpredictable, and the risk of serious, catastrophic injury is very, very real.
We absolutely love exploring the science behind everyday things, but always in a safe way. So with that in mind, what's an object you're curious about? What material properties do you want to understand better? Let us know in the comments what you think we should analyze and explain next.
And definitely make sure you join us for our next explainer, where we're going to stay on this very important topic. We're going to be crushing the myths and testing the facts behind common workshop safety wisdom. You are not going to want to miss that. We'll see you then.